This is the first lesson of Chapter 8, dealing with geometry, and the name of this lesson is Perimeter and Circumference, and this is pre-algebra. Perimeter and circumference are very similar in what they mean. Perimeter is basically the distance around something, or if we were to build a fence around this yard, we would start here and take the lengths of each of the sides, add them together, and that would give me how much fence I need, and that would be the perimeter. Perimeter means distance, measured distance around. And circumference, on the other hand, is the exact same thing as perimeter, but it's dealing with how far it is on a circle from here all the way around to there. So that's the difference between perimeter and circumference. And if you look at the definitions section at the beginning of this lesson, it talks about a polygon. Polygon basically means something that has many sides. It's a closed geometric figure, which means that it doesn't have any openings. You can't get into this figure from the outside. This would be an open figure. You can get into it easily, whereas the closed one, you cannot get into it. And it says a polygon has at least 3 sides, in which each side is a straight line segment. So this would be a polygon. This one we could put 4 sides on it, but if we only made it that long, you could still get into it, and that would be called an open figure. So a polygon is a closed figure, and again, the perimeter of the definition there is any polygon, or of any polygon, is the sum of the lengths of the sides. And we're going to write it as P. P represents the word perimeter. Circumference is a capital C. So in some of the review sections clear back at the beginning of the semester, we found that the perimeters of squares and rectangles and triangles were the addition of all the sides. And in this particular section, we're going to use another polygon, and this polygon is called a parallelogram, and it's spelled big long word. And what that means is a parallelogram means that the opposite sides, so say this side and this side, are going to be parallel, and this side and this side are going to be parallel to each other. So anyway, the way to solve the perimeter of a parallelogram is going to be the same as solving the perimeter of a polygon. So you're just going to add up the sides. So if you were to look at example 1, and we've got a rectangle, and it's 5 yards and 8 yards, and we're going to assume, because it's called a rectangle, that the opposite sides are going to be parallel, which means they're going to be the same length. And we've got those there. We're going to add up all of the sides, and we're going to get our answer. So we can add up all of our sides. Okay, so what we did is we just took the length plus the width plus the width. And another way of writing this formula here is 2 times the length plus 2 times the width, or 2 times 5, which is what we have here, plus 2 times 8, which we have here. So this would be another formula for writing it. You get the same answer either way, but that's how we do that. And example 2 gives us 4 different parallelograms, and they're asking us to find the perimeter, and all you're doing is adding up the sides. So I'm not going to really go over that example. You can do that on your own. It's not too bad. And so then we'll look at circumference here. And circumference, again, is the distance around. And the circumference in this section on circumference gives you some basic definitions here. Let's go ahead and draw a real lame circle here. The distance from the center point to any point out on the circle is called the radius, and it's designated with the letter R. The diameter is the distance from one side of the circle through the center point to the other side of the circle, and we'll call that D. So all of these are D's. They go from one side to the other, and they all go through the center point, and all those D's are going to be the same. The diameter is always going to be 2 times whatever the length of the radius is. So just double it, and you've got the diameter, or take half of it, half the diameter, and you've got the radius. And we also have pi. You're familiar with pi, and that's 3.14, and it goes on forever and ever and ever. But if we were to just look at it for what we're going to be doing, you can use your pi key on your calculator, or you can use 3.14. When you use 3.14, or really anything on your calculator, the pi key, you're just getting an estimate or an approximate, because the decimal goes on forever. So anyway, if you use your pi button on your calculator, you're going to get a lot closer answer than if you use 3.14. But as long as you're within, a couple decimal points there, you're going to be fine. I'm just more interested in you getting an answer that is close to being exact. I'm not interested in you getting necessarily the exact answer. So if, let's say the book gives you an answer of 64.16, and you plugged it in your calculator and you got this answer, they're both fine. So don't get too caught up with being exact there, because whenever you're dealing with pi, you're just dealing with an estimate. So the circumference of a circle is going to be C, your circumference, equals 2 times pi, 3.14, times your radius, or some people would rather write it as, because we talked about 2 times the radius is the same as the diameter, pi times the diameter. So both of those are correct, and either one you can go ahead and use. So if you look at example 3, it talks about a euro coin having a diameter of 23.25. So since they gave me diameter, I'm going to use this formula, C equals pi times 23.25, and I'll find the answer there. Now if you look at the B part of example 3, it gives you the radius of 0.52. So therefore I'm going to use this formula, C equals 2 times pi times 0.52. So we'll get our circumference that way. Now notice I could have used this formula right here, pi times diameter. All I would have to do is double this, and it becomes my diameter, and then multiply it by pi up here. But that's the same thing I did here. I took my 0.52 and I doubled it. That's what this 2 means, is I doubled the 0.52 and then multiplied it by pi. In example 4, it gives us a diameter of an inner tube. So we've got an inner tube right here. And the diameter would be the distance from here through the center point to here. And they're telling me that diameter is 42 inches. And they're interested in the circumference. Well, we know the circumference is pi times diameter. So we're going to take 3.14, or just click the pi button on your calculator, times 42, and you'll get about 131.88 or 132 inches. Now, when you're given something like 132 inches, that's such a big number in inches, a lot of folks will want to convert that to feet. So if you remember in the last section, or some chapters before, we did conversions. So we would take 132 inches times line inches. I know there's 12 inches in 1 foot. I can cancel that and cancel that, and take 132 divided by 12, and that would give me how many feet across that inner tube is, and it's going to be around 11 feet, so it's quite a big inner tube. And if we look at example number 5, well, before we start that, let's look at circles in the earth. There are many circles found on the surface of the earth. The most familiar are latitude and longitude. Of these circles, the ones with the largest circumference are called great circles. And there is a picture of the Earth right there. Notice one of the great circles is the equator, and the other great circle is right there, called the prime meridian. And notice we have longitudinal lines that run north to south, like this. And my latitudinal lines run east to west, like this. And you can find, this is how they use GPS, and on your maps you can find out, well, if you look at Alaska, you can notice that right over here, you can find out where a place is anywhere in the world based on where those two lines cross. So if you are right here, you can find out your longitudinal line and your latitudinal line, and you can determine where you are right there. So whenever you're using a GPS and it gives you lat and long, that is telling you exactly where you are based on these lines. So anyway, if we look at example 5, it gives us, let's move this up out of the way here. If the circumference of the Earth is approximately 24,900 miles at the equator, so we're talking about the circumference. We're talking about if I were to take this little picture here and draw a line, and let me use black ink here, around this thing all the way around here, the distance from here all the way around and back again would be 24,900 miles. Alright, so what is the diameter of the Earth to the nearest 10 miles? So what they're asking us to do here, again, make this big again, they're asking us how far it is from here to here, all the way across here, the diameter. That's what they're interested in finding out. So given the information that we have, they have given us just the circumference. So we know circumference equals pi times diameter, and we're looking for this. So we know the circumference is 24,900, and that equals pi, 3.14, times the diameter. Now algebraically, you know that any number multiplied by your variable is going to be divided by both sides to get rid of it on that side. So that will cancel and that will cancel. So if we take 24,900 and divide it by 3.14, we get 7,930 miles. So from one side of the Earth all the way through the center to the other side of the Earth is 7,930 miles. So it's 7,930 miles thick at its biggest diameter, or at the equator. And that is it for problem, or the lesson 8.1. And if you look at the problem sets, there really isn't a whole lot there. I will just kind of go over a couple of them with you in the next video, so jump over to there right now.